Hi everyone. In today's video, I am finishing the Unit 9 review. I am just doing the back page, so this should be a short video. Number 21, label each function below as exponential growth or exponential decay. The difference is very easy to tell. You look at the number in parentheses. Growth is more than 1. So decay is going to be less than 1. That's it. 0.25, that is less than 1. This is decay. 3/4, also decay. I don't know what I was starting to write. Decay, there we go. 1.75, it is more than 1. It's bigger than 1. So this is growth. And lastly, we have a 6. That is clearly growth. It's bigger than 1. That's number 21. Read and answer the following exponential growth or decay word problems, and they give us the equation we need. A of t equals little a times 1 plus or minus r to the t power. And I do want to do a quick review of what each of these mean. So big A of t, this is the final value. And I'll have another name for this. I'll come back to that when I get to little a. Little a is the starting value. And you can think of little a and big A as before and after. It's kind of squished, but that's the word before. So little a is like before and big A is like after. So that's one way you can tell them apart as well. And then R is pretty easy. It stands for rate. And T stands for time. So those are our different letters. Just a quick review of that. All right, 22. The value of a certain baseball card increases in value at a rate of 3.6% per year. So clearly that's going to be R. And it says it increases. That's good to know. The current owner of the baseball card plans to sell the card at an auction when the estimated value of the card reaches $255. We know this is important, but it's kind of vague what it is, so I'm going to come back to that. The card is now estimated to be worth $212. How many years will the current owner wait to sell the card? Select the correct equation to set up the scenario. So it helps to kind of plan your equation. So I have A of t, A, R, and t. Okay, let's start with the rate. We know for sure what that is. It is increasing at 3.6%, so this is plus 3.6%. Reminder, we can't plug percentages into this equation, so we'll have to move that decimal place 2 to the left to turn it into a decimal. We'll end up with a 0 there. So this becomes 0.036. Now, from here, it says how many years, and that is the time. That's how long. That's what we don't know. So t is the unknown. You can also clearly tell that by your options. Okay, figuring out which one is big A and which one's little a. It comes down to that before and after thing. So let me read those middle two sentences again. The current owner of the card plans to sell it at an auction when the estimated value of the card reaches $255. The card is now estimated to be $212. So the person who owns the card wants to make money off of it. He wants to wait until the card is worth $255. Right now it is only $212, so it's not there yet. But the rate says it's going to go up eventually. So our before and after. Right now it's $212. When it's $255, he will sell it. So before is $212. After is $255. So that's how I know. So let's plug it all into the equation. We have A of t equals a times 1 plus or minus r to the t power. We now know a of t is 255 equals little a is 212 times 1, we decided this is a plus, I forgot to write it over here, plus 0.036 to the t power. And then lastly, let's simplify inside the parentheses before we choose our answer. 255 equals 212 times 1.036 to the t. And then we look for the equation that looks like that. And it looks like it is A. Notice B is a close second. The only difference is these numbers are switched. Now, B doesn't make sense, though, because if you really think about it, if these numbers are like a before and after and it's going up, why would the before number be bigger than the after number? Just think about that. These are some things to kind of think about that will help lead you to the right answer. Okay, 23. The value of a used car decreases, that's an important detail, 9% per year. If the current value of the car is $12,500, write the function that represents the value of the car in 5 years. That's going to be our t, and 9 is going to be our r. And then, again, the wording can be a little deceptive at times. So this is either little a or big A. So let's start by just writing out our variables. A of t, little a, r, and t. We know that t is 5. Now the value decreases 9%, so this is a minus 9%. Once again, we have to have a decimal, so put a decimal behind the 9 and move it 2 to the left. We'll have a 0 in there. Minus 0.09. Now, we have to figure out which one we are missing and which one we have. Now they're asking if the current value of the car, if right now the car is $12,500, write the function to represent the value of the car in 5 years. So again, think of this as before and after. Before, right now, we're at $12,500. This value is going to go down over the next 5 years. They want to know what it will be after the 5 years. That's what they want us to find. We don't know. So the after is the unknown. The $12,500, that's how much it's worth right now. And it's only going to go down from here. So my function, if I'm putting this all together, the equation is right up here on the right for you to reference. A of t we don't know. So we have A of t equals little a is 12,500 times 1, and then this is a minus, we have deduced that, 0.09 to the 5th power. And then the better equation is to go ahead and simplify inside of the parentheses. So my final answer for the function is A of t equals 12,500 times 1 minus 0.09, I believe that's 0.91. I do not want to be wrong here, so I'm going to check. Yep. 0.91 to the 5th power. So that's my function. Now my solution, I just need to put that into my calculator. So I'm going to write that up here again. Just going to copy that down. And then you just plug all of this into the calculator and you'll get the answer. 12,500 times 0.91 to the 5th power. And it says to round to the nearest cent. We are dealing with money, so that makes sense. This will be 2 decimal places. 2 takes us out to 40. The next number is a 1, not big enough to bump this up any further. So this is my answer. 78,000. Ooh, no. Let me rewrite that. I misread it. It's kind of hard to read from here. Okay. A of t equals, that's 7,800. Yeah. $7,800.40. So if I want to put the comma there, it needs to go in between. I wish I could sell my car for $78,000. That would be wonderful. Okay. So yeah, if the value is going down, that makes sense for sure. So that's our answer. Last problem, 24. The initial population of species of fish is 355 fish. So the words initial, this is starting, this is before. So 355 fish, that is our little a. The species is increasing at a rate of 10%. So that's our R. Approximately how many fish will be there after a total of 11 months? And I forgot to change these to years, so let me do that real quick. Per year and after 11 years. So that is going to be my T. Round your answer to the nearest whole number. We are talking about fish here, so that makes sense. All right, let's set up our equation. We have a of t, little a, r, and t. Okay. Little a, we started with 355 fish. And the species is increasing, so that's plus 10%. Once again, no percents allowed. Change this to a decimal. 1, 2. So this is plus 0.1, and then 1 or 1, 0, it doesn't matter. Plus 0.10 if you like. And after 11 years, how many fish will there be? That's the question. So big A of t is the unknown. Let's put this together into an equation. And the function is not in view, so I'll write it again up here. A of t equals little a times 1 plus or minus r to the t value. So we have a of t equals little a is 355 times 1 plus 0.10 to the 11th power. And let's make that better by simplifying inside the parentheses. A of t equals 355 times 1.1. I'm going to drop that extra 0, but if you include it, it's fine, to the 11th power. This is my function, and then I'll put the right side into a calculator to get my answer. So I'm going to copy this over again on the right side. A of t equals 355 times 1.1 to the 11th power. You don't necessarily need to copy that down again. I'm just showing where that answer is coming from. And we're going to have to round for sure. 355 times 1.1 to the 11th power. And we're rounding fish. Now we can't have a partial fish. So this is one of those scenarios where even if it goes over, we're going to completely ignore it, and it's just going to be 10, 12. And I'm looking at my answer key says 10, 13. So honestly, we'll be lenient on this, but if we're going to get technical, it's 10, 12. We can't have 0.8 of a fish. So that's how many fish we have. 1,012 fish after 11 years, which is incredible growth for sure. So it's close enough. If you put 10, 13, I won't mark it wrong. I'll be nice about it. Okay, that's all for the backside. If you have any additional questions over this material, feel free to reach out to me via email or come see me in person. Otherwise, I hope you have an awesome day. Bye.